first one's linear, and the next two are rational, which you graphed rational functions this year in Precalc, and then you also graph them in Algebra 2 Honors. Okay, so if it's a rational function, do you guys remember the name of the graph that it makes? Start with an H. Hyperbola. It is a hyperbola. Okay, so like when you were graphing, you'd see different things like this. Well, this one would be more flat. Okay, so it would look like this, or like there were some that we did this year that look like this. And what's happening in between these values? Okay, and they're undefined because what's there? Yeah, there's going to be asymptotes here. So for g of x, when you get to this one here and you are plugging in 3, on the bottom you're going to get 0. So you end up with 0 over 0, and we're going to talk about that today. If you have 0 over 0, we call that an indeterminate. So because 0 is on the bottom, it is undefined. But technically, if you have something over itself, we usually think of that as what? 1. Okay, so this is indeterminate or an undefined value. Can you guys think about why that would be undefined for the rational function? What's happening there? Okay, there's going to be a vertical asymptote that's going to occur at x equals 3. Do you guys remember we found those? You'd set the denominator equal to 0 and solve. Okay. Did anybody notice that you could factor this one? Okay, so if you factored x minus 3 times x plus 3 over x minus 3, those cancel out, which means when you're plugging this in, you can use x plus 3 for all those, because look at your two columns. Didn't all of these match? Weren't these all the same? Yeah, because they were just both x plus 3. The only difference is the domain. The domain for this does not include 3 because you would get a 0 on the bottom. Do you guys remember from Algebra 2 Honors what happens in this type of situation, like what you'd see on the graph? It is going to be a line. So it's going to be the line x plus 3. All right, we'll talk about it in a minute, and I'll let you think about it, because we're going to go over it on the math is fun. So, same thing with this. 1 over x minus 3, it is going to be undefined when you have 3 there. Now, with the first two, it looks like they're getting closer and closer to which value? Yeah, they're getting really, really close to 6, right? In fact, these would round to 6. Now, this one is different. So this is approaching negative 10,000. This is approaching 10,000. So in a graph that's like that, it'll be more like this. See how as I get closer and closer to 3, look at the way the line is going. This line is going down to negative infinity. But if I'm looking at it from this side, it's going up to positive infinity. This is actually a case where a limit would not exist. We're going to talk about that a little bit more today. But you can see as you're getting closer and closer to a fixed value for x, you do have two different ways that the graph is going. Okay, so it's not going to the same value. So for 1 and 2, you are going to say that it is approaching the number 6. It's getting very, very close to 6. But for the last one, it looks like from one side it's approaching infinity. From the other side, it's approaching negative infinity. You guys have actually seen what it looks like when it approaches from the left and right, because there was one on your midterm. I don't think it was a limit, but you had like x goes to 3 plus. So if you see this means it's going to 3 from the right side. And then if you wanted to say the left side, this would be a negative. So this is approaching from the left. This is approaching from the right. All right, so then I asked you in your textbook to find the definition of the limit and then write that down. So you should have your definition of the limit using symbols and how we say it in words. this and then I'll let you fill in the rest of it. So what this means, the limit of some function f of x as x approaches a is going to equal the value L, which we do say is the limit. Now, if you say as x goes to a, do any of you think you could tell me what that means? The limit as x goes to a? Like, what's x and what's a? Yeah, Jonathan?
A is just any number.
Mm-hmm.
And x is just getting very, very, very close.
Okay, good. So it's saying when you look at the x values as it gets closer to any number a, you're going to say what it's approaching. So whenever you're doing a limit, okay, the main thing that you want to realize about a limit is that it approaches, okay, it approaches a certain value. Okay. All right, so we're going to look at the Math is Fun website, and while I'm pulling that up, I'm going to have you write down our title for today, which 13.1 is finding the limits numerically and graphically. And we're going to estimate the value of a limit today using tables and using graphs. Show you this on my phone just so I can record it. So if you're looking back at this, you can see what we're referring to. We'll try it out. Okay, so we're going to start talking about limits, which is something that you'll use when you get to calculus. So another way you can find this is if you do Math is Fun, and then limits, and then it pops up first, limits and introduction from Math is Fun. Okay, so limits are helpful because sometimes you can't work something out directly. Okay, if you can't work something out directly, then what you want to see, what you want to investigate is what happens as you get closer and closer to it. So here's an example. Okay? If we tried to find out what this was for 1, if you plug in 1, you're going to get 0 on the bottom and 0 on the top. What did I tell you that was called today?
Undefined.
Okay, so no, if you have 0 over 0, it's called indeterminate. Okay, so 0 over 0 is going to be an indeterminate value. However, if we instead make a table of these values, and you don't have to write this down, you can just listen. Okay? If you make a table of these values and see what happens as it's getting closer and closer to 1, you can see from this side of the table that what value are we approaching? Yeah, we're approaching 2. We would say this is approaching 1 from what side, the left or the right? From the left side. Okay? And then we also have to see what happens when we approach it from the other side, which we're going to do in a minute. The way that you would write this in symbols for your limit would be the limit as x goes to 1 of your function, and then that would be equal to 2. Okay, so it's like we're saying, let's ignore what happens when we get there because that's indeterminate, but let's see what happens when we get closer and closer to 2. Now, I asked you a question a little bit earlier about, what happens when you have the x minus 3 over the x plus 3, and you have x minus 3 on the bottom? Okay, and now we can see what's going to happen. What is it? It'll be a hole at that part in the graph. Because look, we have x squared minus 1 over x minus 1. What can that factor into? X squared minus 1 over x minus 1. What does that factor into? X plus 1, x minus 1 over x minus 1. So those would cancel out. So there would be a hole in the graph at x equals 1, which is hard to see on your calculator unless you zoom in really far, but your hole is going to be there. So that's why we can't say that it's equal to 2, but we can say as it approaches that it will be 2. Now, you do want to test both sides and see what happens. So that's why we test things from the left and from the right. So if we test it from the right and the left for this one, they're actually going to meet at the same place. So it'll be the same exact value. It'll be the 2, but that does not always happen. Okay, so if we approached 1, but now we're approaching from the right side, you can see it still is getting closer and closer to 2, which is why that limit exists. Sometimes you're going to have a case that looks like this. Okay, so let's say I'm running up this hill, right? If I get to this value, whatever my A value is, I'm going to end up at 3.8. If I approach it from the right side, I'm going to end up at 1.3. If you approach from the left and the right and they are not at the same value, that is when the limit does not exist. Okay, is when they're approaching two different values. So it could be a certain value like this, or it could be one's going to infinity while the other's going to negative infinity. Okay, so there it is. The limit does not exist. So not just a thing from the movies, right? But that's what we think about Mean Girls. Yeah. That's how she wins the math league competition. Now, the next thing it says, are limits only for difficult functions? No. I could do the limit of, as x goes to 10, of x over 2 equals 5. If you plug in 10, 10 over 2 is going to be 5. We know that. We could still use the limit if we want to. It's just, it's not going to be very valuable information because we already know what's going to happen there. Whereas when you do have indeterminate values, that's where it's going to be more useful. Now, like I said, you can approach infinity or negative infinity, but that is going to be not a number. Infinity is an idea. Okay? So if it is approaching infinity or negative infinity, then it's also not going to exist. We don't know what 1 over the value of infinity is, so that is an undefined part of the function. So if it is undefined, that's a good time to use your limit so that you can approach it and see what happens as you get very, very close to a given x value. All right, and then that's where we're going to stop with that. So what we're going to do is we're going to do a very similar limit, and you can just put that somewhere in your box, wherever you have room. So we're going to find the limit as x goes to 2 of x squared minus 4 over x minus 2. Somewhere in the box on your note sheet. Okay, so wherever you have room. So what we're going to do is we're going to make a table. Now, we can see this is the limit as x approaches 2. So it's good to have a few values from the left and from the right. Okay, so this is just one way that you can write it. You do want to have different decimal places. This would be approaching from the left. Okay, which if you're approaching from the left, it's going to be lower than the value. If you're approaching from the right, it's going to be higher. X squared minus 4 over x. And it's the limit of x approaches 2. Oh, x minus 2. Okay, so I'm not sure if you did this when you were filling out your chart on our first worksheet, but I highly recommend that you use your table function. Okay, so to use your table function, you can do x squared minus 4, and because it is a rational function, you do want to put that in parentheses. Okay, and then if you want to just go right to your table and be at the value that you started with, so we chose to start at 1.5, you could go by like 0.01, and you'd be able to run into a few other values. So when I go to my table now, at 1.5, I'm at 3.5. And then see how this would kind of take a while to get to 1.9. I mean, I could get there this way. For the next one, I'll show you a different way you can do it. So at 1.9, I'm at 3.9. And then at 1.99, okay, I'm at 3.98. Okay, so then I'm going to write those down for my y values. So, okay, let's say I'm jumping over here to 2.001. So I can jump back to the table and get the 4.001. And then if I don't want to scroll, I can just keep going back to my table set to find out what I want. Okay, so 2.01, and then 2.10 or 2.1 would be right here. So that's a nice way to get your table. And then looking at our table, it looks like all the numbers are getting really, really close to what? Yeah, they're getting really, really close to 4. Okay, so then we would say that the limit as x goes to 2 of x squared minus 4 divided by x minus 2 is equal to 4. Okay, and then as we do the next example, I'm also going to go over how to pick out values for your table